Hey everyone, in this video we are going to solve merge k sorted linked list. So we are given k linked list. So and each linked list is in sorted order and we need to return a single sorted linked list as an output. So as you can see in this case we got three linked list here 145, 134 and 26, and as an output we return them a single linked list in a sorted manner. So this is the question. Let's see how we can do it. So we are given these three sorted linked list and we need to return one sorted linked list. So what we can do, the first way could be to go through each one of them and keep comparing them. But one another and better way could be to divide it into sub problems. So we'll sort these two. So we'll focus on merging two linked lists at a time. We'll merge two linked lists and then we'll merge the result of those two linked lists to the next linked list. So let's see what do I mean by that. What we'll do, we'll create a function. We'll call it, let's say, merge lists. It will take two lists. Let's call them A and B. And we need to merge these two linked lists at a time. So let's say we pass these two to the function first. So what it will do, so we'll create a dummy node first. So a dummy node which will initially point to list node 0. Then we'll check if A or B, which one is smaller. In this case, both are equal, so we can take any of them. So let's say 1. We'll take the B1 and then we move B one step forward. Then in these two cases, which one is smaller, A or B? A is smaller, so we take A and move A one step forward. Then we'll again check which one is smaller, it's B. So we take B and we move B one step forward. Same, this another case, A and B both are equal, so we can take any one of them. So let's say we'll take let's say we take 4, this one, and we reached null here. Then after that we can say if any one of them is pending, if any one of them is null and the other one is not null, we can just add the remaining one after that, and at the end we'll just return this linked list dummy node dot next. So we'll have 1 1 3 4 and 5. Then again we'll pass these two linked lists. So this one, the one we get by merging these two, and the third one again to the merge list function. It will again repeat the same process. So we'll have one pointer here, one B pointer here, and a dummy node pointing to list node at 0. So we'll check which one is smaller. A is smaller, so we'll add A here. Then we'll move A one step forward. Then we'll check which one is smaller. Still A is smaller, so we'll add A here. Then again we'll move A one step forward. Then we'll check which one is smaller. It's B, so we'll add B here. Then we'll move B one step forward. Then we'll check which one is smaller. It's A, so we'll add 3 and move A one step forward. Again A is smaller, so we'll add 4 and move A one step forward. Then we'll again add 5, and at the end A will become null and we'll add the remaining list at the end, which is 6, and from inside this merge list function we'll return dummy.next, which is this particular linked list, as output. So the time complexity for this one will be n log k, where n is the total number of nodes in all of these linked lists, and k is the number of linked lists we have, because we are merging these two first, and then again the result we got we are merging these two first. The space complexity will be O of n, since we are storing all of the nodes in a dummy list at a time. So this is the drawing explanation. Let's see how we can do it in code. So let's first handle the edge case. So in case if no list are present. So if list dot length is equal to 0, we'll just return null. After that, we'll run a while loop, and inside that while loop, we'll keep checking if list dot length is greater than 1. Then we'll take two linked list out of it. So a equal to, okay, it is lists, list. Okay, so list dot shift will get the first array or the first linked list from a lists array. Then again one more time to get the another linked list. Again lists. Okay. Then we'll pass these two to our function merge list. A comma b will create this function soon, and then at the end we'll just add lists dot push h, and at the end we'll return lists at 0. So let's write this merge list function first. So let's create an arrow function for it. So merge lists equal to a comma b, and inside it we'll create a dummy node first. So dummy equal to new list node at 0, and let's create point temp to dummy, a temp pointer. Then we'll run a while loop while a is not equal to null and b is not equal to null. What we'll do, we'll keep checking if a dot val is small or b dot val is small. So if a is small, we'll add a to temp dot next and move a one step forward, a equals to a dot next. Else we'll add b to it. So temp dot next will be b, and we'll move b one step forward. So b equal to b dot next. And in either way, we'll move temp one step forward as well. So temp equal to temp dot next. And at the end, we'll check if any one of them is not null. So if a is not equal to null, that means there are some values present in a. So temp dot next will be equal to a. Or if let's say b is not equal to null, that means there are some values remaining in linked list b. So temp dot next will be equal to b in this case. And at the end, we'll return dummy dot next from this function. So this is the code. Let's run it. It's working. Let's submit it. Cool. So that was it for this video. Thank you for watching.